So I think I hope everybody is able to hear me. Good evening, guys. Are you able to hear?
Yes, sir.
Okay, good, fine. So say we are almost in the third class for this chemistry class, right? So the situation around us is not so good, right? We are like seeing the number of cases raging, say every day, right? So make sure you're safe, right? Make sure you don't go out much, right? Even if you go out, as the government tells us, wear masks and all that, so maintain social distancing. So it is going to be a little tough for some more time. It'll be fine. Right? So till then, it's our responsibility to uh, make sure that we are safe and as well as our families are safe. Right? Okay, fine. So we'll start. So we didn't actually go into the chapter. The chapter name is eventually chemical reactions and equation, but we really didn't go into the chapter yet. And obviously, you should know why, right? Because we were learning the basics, how to write the chemical formula. Then only we can talk about chemical reactions and equations, isn't it? Right? So till now, we saw monoatomic cations, monoatomic anions. What do you mean by monoatomic cations and anions? Can someone tell me? What do you mean by monoatomic anions or cations? What do you mean by that? Even if it's a rough guess.
Sir, in monoatomic ions, only that element will be present, sir.
Absolutely, absolutely. That's how it is, right? Only that. Okay, one thing is only that element should be present, and also only that element. Also, the number of that. Say, even if I talk about sodium ion, it's made up of only sodium, but okay, it is made up of only sodium and only one sodium. That's the point. One atom becoming an ion. Mono is one. So that one talks about the number as well as the type, right? Anyways, so as you tell, that's the correct answer. If it's made up of only one type of element, that is going to be monoatomic, right? So now when we went on to see how do you form when I have monoatomic cation, monoatomic anion, how do you write the formulas? First of all, from the atomic state, right? First thing, any compound given to you, any compound, if it's monoatomic, sodium fluoride or calcium oxide, something, right? So only two elements, calcium, oxygen, magnesium sulfide, something like that. Only two elements if they give you, right? The first step, what will you do? Can someone tell me? Like, how will you try to write the formula? So the first step. Say if I give you some AX, right? Something, right? A is an element, X is an element. Okay. So what is the first thing you'll do? How do you for writing the formula?
So first we have to write the atomic number and the electronic configuration, sir.
Correct. Then what should we do? Okay. Yeah.
Then we have to use the crisscross method.
Okay, that's it. Once you know the atomic number, you write the electronic configuration and directly you go for swap. There is nothing in between.
Sir, we have to find the formula for the atom, sir.
What do you mean?
Ion,
what do you mean by formula for the? Okay, correct. Okay, I understand what you're trying to say. So there's only one word which I'm looking for.
Valence electron.
Okay, that's fine. Well, with valence electrons, another word, important word.
We have what are you going to do with the valence electron?
Okay, fine. You have to keep it more stable. You're getting closer. Again, the one word. You're getting closer to that one word. How do you make it stable?
So by adding.
So by making octet rule, sir.
That's what. Correct. That's the exact word I'm looking for. Octet rule or duplet rule, depending on what the element is speaking about. Right. So someone said valence electron. Someone said stability. Someone said something. So eventually, what it leads to is octet rule, which says that the number of valence electrons should be 8. Right. So for that you do something. And someone said you have to add electrons, remove electron. Yes, all these you have to do for what? For making sure that the atom gets stability. And how are you going to make sure that the atom gets stability? That is where octet rule comes into the picture, making sure that you have 8 electrons in the valence shell. So for that, you remove electrons, add electrons, and you make, okay, fine. After doing octet rule, okay, fine, I understood octet rule. Then what you have to do? So again, I repeat. First, you write the electronic configuration. First you know the atomic number. Then only you can write the electronic configuration. Then you look for octet rule. Okay. Then you add or remove electrons. Okay. Then what do we do? After removing or adding electrons, then what will you do for writing the formula?
So then crisscross method, sir.
Okay, so crisscross method. So the point you're missing is you have to form the cation and the anion. Basically, there will be two elements, right? So one of the element will be gaining electron. Obviously, the other element has to accept, has to lose electron. One gaining, one losing, right? So obviously, those two things will happen, right? So if an element loses electron, what will it form? What is the name? What is the name of a species which will form? An element loses electron.
Cation, sir.
Cation. Positive charge. Cation. Exact word is cation. Correct. Cations. Right? So cation obviously will be positive charge or negative charge?
Positive.
Positive.
Positive charge. Obviously. Why? Because you're losing electron. From neutral something, you remove electron to form a positive species, which is cation. Obviously, it will be exactly opposite for anions. Anions will be negatively charged, and though they will be formed by atom accepting electron. Right? Okay, fine. Now you would have. Now, how do you decide what is the magnitude of charge? Whether it's 1 plus or 2 minus or 2 plus or 3 minus, something like that.
Sense?
Magnitude in the sense the number. You write 1 plus, or generally you write just plus, or you write 2 plus, or you write 3 minus, or you write 2 minus, something. The plus or minus we understand how do you get a form, but what is how do the number decide?
So depending upon the number of electrons, the element lose or gain, sir.
Okay, fine, I understand. So it is based on how many number of electrons that element accepted or it lost. Say for example, if it has lost 2 electrons, then the charge would be
2 minus.
2 plus.
2 plus. If the element has lost 2 electrons, obviously the cationic charge would be plus 2. Right? Same way, if I say that the element has gained 3 electrons, what will be the charge?
3 minus.
3 minus.
3 minus. Right? So like this, now only the last method. Now you found out what is the charge on the cation, what is the charge on the anion. Then you crisscross. Then you get the formula. Yes? Correct? Okay?
Yes,
so
sir.
these are all the step-by-step. This is, see, like, you please do not be lazy. Right? Say, you try to know the formulas, but if you forget the formulas, right, what do you have to do? Just have some patience and do this, whatever you have learned, and you will get the formula. But again, you have to remember the atomic numbers. If not, that's the first and foremost step. If you don't remember that, no, things will be difficult. Okay, so then we went on to see something called as polyatomic ions. Okay, so monoatomic means we said that it is only one type of element or only one atom present in the ion. Okay, so polyatomic means, as we already discussed, it is going to be made up of more than one type of element, right? More than one type of element. Say I can have sulfur, oxygen, or say nitrogen, oxygen, or I can have nitrogen, hydrogen, or I can have oxygen and hydrogen, something like that, right? More than one element to be present in a particular ion, right? So that's what we call it as polyatomic ion. Okay, fine. So let me ask you a question. From the name of the ion, right? From the name of the ion, how will you know whether it's a cation or an anion? Say if you know the formula, if you write plus or minus, then you obviously know that it's a cation or anion. But by looking at the name of the ion, how will you know whether it's a cation or anion?
Sir, it ends with IUM.
So if it ends with IUM, then it is a cation, sir.
Good.
If it ends with IDE, ITE, or ATE, it means anion, sir.
Okay, good. Right. So if it ends with IUM, sodium ion, we don't write for sodium element also we say sodium only. For ion also we'll say sodium only. But anyways, we say just maybe we just add the thing sodium ion. Right. Anyways, so IUM, if it ends, right, it's going to be a positive charge cation. Right. And then if at all if it ends with E, the letter E, then it's definitely a anion. And depending on what the three things you said, IDE, ITE, and ATE, right, I will be able to tell what type of anion it is going to get formed. Okay, we'll discuss more. So what do you fine if I have the name ends with IDE, what you can conclude about that anion? Obviously, E is there, anion. If it's IDE, what you can conclude about it?
So only that element is there, sir.
Sir, it's monoatomic anion.
Correct. Right? So only one element is there, and obviously it is going to be not okay. In this case, we cannot call it as monoatomic because sometimes you can even have ions like this O2 2 minus. This is polyatomic, but it is made up of only oxygen. So I hope you understand the difference. Monoatomic, not necessarily that it is made up of only one element. Obviously, it is made of only one element because only one magnitude number will be there. See, you see two here, two oxygen atoms. If I write Na plus or O2 minus or whatever it is, you see only one, here one. Only one sodium plus, only one oxygen atom becoming O2 minus, something like that. Okay, so anyways, I don't want to confuse you, right? So what I can understand is they are going to be made up of only that element. For example, oxide will be O2 minus, nitride, IDE, again, sulfide, or phosphide, something like that. Whenever you see that, it is going to be only that element. Okay, good, right? So now, fine. Now I'll be able to see these two together. I can have ITE and ATE together. Okay, fine. So you do AC any of this. What do you decide?
Sir, the element is present along with oxygen, sir.
That's it, right? So the element for another element, if you're going to end with ATE or ITE,
the number of oxygen atoms in ATE will be more than number of oxygen atoms in ITE, sir.
Absolutely. Correct. Right. So first thing is, the moment you see any of this ITE or ATE, right, you can understand that they're going to come along with oxygen, right? Sulfate, sulfite, nitrate, nitrite, phosphate, something like that, right? So all these comes along with oxygen, sulfur plus oxygen, nitrogen plus oxygen. And as you said, what is the difference between ITE and ATE? The number of oxygen atoms in ATE will be one greater than what I had here. If at all I had 3 in ITE, 3 oxygen atoms in ITE, then I will have 4 oxygen atoms in ATE, right? So we saw the example, I guess, SO3 2 minus and SO4 2 minus. This is sulfite, this is sulfate. You can see the difference is 1. 3 oxygen atoms, here 4 oxygen atoms. Same goes with nitrite and nitrate. Can someone tell me what is the formula for nitrite and nitrate?
Sir, nitrite NO2 minus and nitrate NO3 minus.
Okay, right. So nitrite is NO2 minus. Correct. Nitrate is NO3 minus. You can again see the difference between the number of oxygen atoms is 1, 2, and 3. Okay, right. Fine. So this is okay. Okay. Now I don't want anybody to open their mics and speak. I want to know what is the formula for carbonate and bicarbonate ion. Okay, just put it in the chat box. I'll see. Put it to everyone so that everyone can see whatever your answers are. Okay. Carbonate and bicarbonate. I want to know the formula. Ions, obviously. Okay, guys are typing. That's why it's taking a lot of time, I guess. Already there is another chat. Okay. Carbonate is Okay, carbonate is CO3 2 minus. Okay, fine. I'll not tell you whether it's right or wrong. Please, everybody participate. I want everybody to put their answers there. I will at last tell you whether you're right or wrong. I will tell you the answer, then you check whether your answer is correct or not. Okay. Yeah, so I'm saying CO3 2 minus, CO3 minus, CO3 2 minus, CO3 minus. Okay. Okay, don't worry about how it looks. Anyways, I understand. However you write it, I will understand. Don't worry. Okay, I hope Almost, yeah, I'm still seeing answers. Good, guys. Almost most of you got it right. Okay, so for carbonate, and for carbonate, you don't have to worry. There is no carbonate and carbonites. No, that thing doesn't exist. Okay, fine. So carbonate is HCO3. Sorry, CO3 2 minus, right? And one more thing I told you. What do you mean by this bi? Like when something
hydrogen. Addition of hydrogen.
Yeah, correct. So bicarbonate means you add one H plus to whatever the formula. Bicarbonate means to the carbonate you add the H plus. So you can easily understand if I add CO3 2 minus and a H plus, it's very easy. I'm just going to make the compound. That's it, nothing else. But what you have to understand is the charge, right? Here you have, it's 2 minus, here it is 1 plus. So 2 minus 2 plus 1 will become minus 1. So for bicarbonate, it should be HCO3. I understand. HCO3, that's done. Charge minus 2 plus 1 will become minus 1, but we don't write. We just write HCO3 minus. There is one more. There is one more element which can do like this, bi and something. Can you name something like that other than this carbonate and bicarbonate? Can you tell me one more pair with bi? I gave you last class, I think.
Sir, sulfite and bisulfite.
Yeah, right. Sulfite and bisulfite. Right? So sulfite, we just now saw SO3 2 minus, same thing. Just add H plus to this, you will get HSO3 minus, 1 minus. Same way, so add the charges, add the atoms, and you will get the formula, right? Now that's it. So we have seen, I don't know what and all we saw. I think I'll just write whatever I missed, maybe, right? Okay. So these are all the things. And then I think we would have seen hydroxide, right? We would have seen hydroxide. What is the formula? Hydroxide ion. From the name itself, you can tell. Right. OH minus. Absolutely. OH minus, right? So you will see in the next chapter that OH minus ion is the one responsible for something being basic in nature. We'll speak about it more in the next chapter. Anyways, right? So then we also saw positive ions. Till now, what you are discussing now are only negative ions, right? We also saw about positive ions, which are polyatomic. Can you tell me 2 of them? We discussed 2 of them last class, I guess. What
Ammonium.
Are they? Ammonium formula.
NH4 plus.
Good. Okay. What is the other one?
Ammonia.
Hydronium.
What is it?
Hydronium.
Okay. Hydronium formula.
H3O plus.
Yeah, H3O1 plus. Same way for ammonium. Again, you see it's ending with IUM, positive charge. The confusion between ammonia and ammonium, now you should be able to understand. Ammonia is a compound. It is not ending with anything. Like literally, E or IUM, nothing. So basically, it's a covalent compound. Covalent compounds generally have this kind of properties. Anyways, right? So ammonia is NH3. We all know, right? And ammonium, as you said, is NH4 plus. One more would be hydronium, which would be H3O plus. Again, H3O plus, you will again study in your next chapter that they are responsible for acidic behavior of what we call acids. Okay, fine. Anyways, so then I don't know what and all you should know. Maybe you should know phosphate, right? So another thing you can know, phosphate is PO4 3 minus. Okay, phosphate is PO4 3 minus. There is no phosphite. There's nothing. Only phosphate. Okay, right. Then maybe what all you need to know, sulfate, all the common things we have known. Anything else? Okay, I think this should be sufficient. Okay, other than this, you don't have to know any other polyatomic anion or cation. Okay, fine. Now we'll just spend little time on writing formulas. It's exactly same as I told you. It's exactly same. The crisscross method is what we are going to see. But one more extra thing, what will you do here is you use brackets, use these parentheses between compounds. If that alone you understand, you are set to write the formulas. Okay, so we'll see some examples. Right. Okay. Fine. So you try this. Okay. Some of you might already know how to use these brackets. Some of you might not know. But anyways, you try whatever the compound I'm going to give you. Let me write ammonium. Ammonium sulfate. Okay. Yeah. Try to get the formula for ammonium sulfate. Not more than 30 seconds. Because you know, you don't have to tell it when you get it. I'll just write, then you check. Okay, fine. I think that should be the time sufficient. Okay, so ammonium, I know, is NH4 plus. Sulfate, we discussed now, is SO4, 2 minus, right? Exact crisscross the charges, not the sign, but the number of the charge. Okay, here it's 1, here it's 2. So 2 will come here and 1 will go here. Now, if it was monoatomic, so if it was sodium, then you would have written just Na2 or Mg2 if it was just magnesium. But you see here, there are 2 elements present. For me to make sure that NH4 plus should be twice. That's what you have to, correct, NH4 twice, SO4. Yes, correct, right? This is how you should write. So this 2 must be covering the entire ion. Please understand, not only sodium, not only nitrogen, not only hydrogen, ammonium ion as a whole, this should be able to engulf. In the sense that you write the formula NH4 entirely, twice, and SO4 in this case didn't have any number, right? But if at all it has some number, then you have to put that bracket, that number. Maybe I'll give you an example. So take, maybe I'll give, I'll give, say, aluminium, aluminium sulfate. No, yeah, right, aluminium sulfate. Right. I'm just giving sulfate, but it's just for you to understand. So see, now it's only aluminium. It's not NH4 twice, SO4 1. No, that you don't have to specify that one, right? That one you don't have to specify here. Not required. It's understood that even if you don't write that. Okay. Right. Fine. So aluminium sulfate. Now remember, aluminium is monoatomic, right? So if you don't remember what charge aluminium forms, then you go back. Go to the atomic number, electronic configuration, octet rule, lose or gain electron, then get the magnitude of the charge. Then you crisscross. Right? Okay, so I think time should have been sufficient, right? Fine. I don't know how many of you got this. Aluminium, I can directly, if you can remember a lot of examples we did, aluminium is aluminium 3+, the ion which it forms. If you don't know, go back. Aluminium has the atomic number of 13. So it will be 2, 8, 3. So it is easy to remove 3 electrons. So 3 electrons lost, 3+. Okay, fine. Now this is SO4, 2 minus electron 3. Right? Okay. Now again, same thing, put this here, put this here. So now Al is a monoatomic. So you see, don't, just because you see 2 letters doesn't mean it is polyatomic. Aluminium, Al is a symbol, 1 element only, right? So you don't have to put a bracket here. So aluminium, the 2 will come here. Now for sulfate, it's a polyatomic ion and that is going to contain 3. So in this case, now you have to put a bracket for sulfate and then you put the number twice. Al2, SO4 twice. Yes. Harita, that's the answer. Al2, SO4 twice. Okay, I hope most of you should have gotten it. One more example, and then we're going into the chapter. Okay, maybe we'll take okay, magnesium nitrate. One more, just last thing. You just try. I'll give you the answer, then we'll move on.
Sir, I have a doubt,
Yeah.
sir.
Yeah.
So in that NH4, sir, 4 is that four atoms of hydrogen.
Correct. 4 atoms of hydrogen, 1 atom of nitrogen. That's what it is.
Sir, and in that SO4, 4 is the 4 atoms of oxygen, sir.
Absolutely. 4 atoms of oxygen.
And 2 is that balance.
2. Now if you check, now in this whole compound, if you want to check, I can tell that there are 2 nitrogen atoms and 8 hydrogen atoms. Already there are 4, twice of that. It will become 8 hydrogen atoms. And this remains same, 1 sulfur, 4 oxygens.
Okay, sir. Understood.
Okay, nice question, actually. Yeah. Fine. So I think most of you would have gotten it. So magnesium is Mg2 plus. Again, if you don't remember, magnesium atomic number is 12, 2, 8, 2, 2 electrons lost, Mg2 plus. Okay, and then nitrate is NO3 minus, 1 minus, right? And nitrite is NO2 minus. Okay, anyways, so now you'll put this 2 here, put this 1 here, so magnesium has nothing. This is the polyatomic anion, so I have to put a bracket to put this 2. Other than 1, whatever you get, you have to put a bracket and write that number. Okay, fine. So now any type of at least ionic compounds I give you, right? You should be able to get their formulas very easily. Okay, fine. Now this is what is the basic requirement for this chapter, right? It's all about how do you write a chemical reaction and how do you convert a chemical reaction into a chemical equation, and so what are the other things you can do about it. In doing that is what we're going to study in this chapter. Okay, fine. So now that we got the basics covered, right? So, and then we already discussed what exactly do you mean by a chemical reaction, right? So 2 chemical species, right? So it's basically for anything to react, for anything not chemically, I'm speaking generally, right? I'm just talking physically also. Say if I take Newton's third law, we already discussed this. For every action, there will be an equal and opposite reaction. In the sense, now we are talking about the reaction already. Now, what is the action we should have done? Basically, we should have made sure that the chemical species or whatever the chemicals are kept in contact. Again, it's not only about the contact, right? What else you have to make sure? Just by making them with contact, obviously after making them in contact and do something else, and what you get the reaction is what your chemical reaction is what you're going to see, right? So now we already spoke about this. Is it enough just for us to keep them in contact, keep them in little close space? Is it enough for them to react?
Passing heat.
Okay, yeah, obviously. So if at all I have to put in a nutshell, you have to make sure that reaction conditions are met, right? For every reaction, small reaction, big reaction, a complex reaction, whatever it is, right? It will happen only at certain conditions. Only if you maintain those conditions, then that particular chemical reaction can happen. As one of them is temperature. Yes, only in that particular temperature the reaction happens. Other thing can be, say, pH. We'll study about it in the next chapter. pH basically tells you how much acidic or how much basic that particular medium is, right? And whether based on that, whether it can be decided whether the chemical the reaction happens or not, right? And sometimes some reactions doesn't happen just like that, right? Even if you provide the conditions, even if you provide temperature, even if you provide whatever, right? The reaction doesn't happen. So in those cases, we go for a help. We take the help of something called as, any guesses what I'm going to say? The one word? Or if I have to, yeah, that's the exact what I was expecting. Catalyst, right? Sometimes the reaction is very, very slow or it doesn't happen.
Sir, what is catalyst, sir?
Yeah. Well, you don't have to worry about it. I'll tell you, right? So I'll tell you exactly what it is. So sometimes the reaction is very slow, right? Or sometimes the reaction doesn't happen at all, but I want the reaction to happen, right? So what you do is you add, other than the reactants, like we'll tell you what are reactants, what are, I think you must have known what is reacting together, or what are called as reactants. So along with the chemicals which are in contact, right, you put one more chemical. Again, it's going to be some chemical species, some metal or something you'll put. That is what is called as catalyst. And what is the role of this? Its role is to make sure that the chemical reaction happens. And or if the chemical reaction is very, very slow, the catalyst role is to make sure that the chemical reaction happens in a faster rate, right? That is the role of the catalyst. Okay, so in a nutshell, in a layman's language, if you have to say what is a catalyst is something which is added to the reaction mixture to make the reaction faster. That's how we can say. Okay, fine. So again, catalyst becomes a reaction conditions, right? So only if you provide the catalyst, the reaction will happen, something like that. Okay, so we already understand what is the chemical reaction, right? And second question is, why even a chemical reaction happens? And this also we discussed. Why does it react? If I just keep something together, why they cannot be quiet, right? Why they cannot just mind their own business and just be in the state where they continue to be? Why they have to react? And for that, what did we say? What did we say? Why a chemical reaction happens? If I ask you. Exactly, they have to be stable. The only one word answer would be stability, right? The chemical species which are getting involved in the chemical reaction, right? They'll be converted to something else, and that gives them stability, right? Stability is what, not only chemical species, we want stability, right? Maybe financial stability or academic stability, whatever it is, right? We also need stability. So that's why chemical reaction happens. Okay, fine. So let me
sir, I do not understand, sir.
Yeah.
So what did
you not understand? Okay, you're telling what do you mean by stability? Okay, see, now if at all you have sodium, say sodium and chlorine. Okay, Cl2 it will be actually. This is how naturally they're available. Okay, sodium as sodium element, chlorine as chlorine gas generally. Okay, now what you do is you take a jar full of chlorine, and then you close it obviously, and you put it near the sodium. Sodium, if you have gone to the lab, sodium it is very soft. You can even cut it with a small piece, and you can make sure that the gas passes through the sodium, the small piece of sodium. Okay, now what you do? What are you doing? You're making them in contact. Okay, now when you make them in contact, I know I'm going to form NaCl. This is not what I want you to understand. What I want you to understand is what is happening in this time, right? What is happening in this time? In this time, I know sodium will form sodium plus, chlorine will form Cl minus, and they will come together, and then eventually NaCl is formed, right? Now, why it has to form Na plus? Why it has to form Cl minus? Now you tell me. Because?
To attain stability, sir.
Exactly. We say for attaining stability, one electron is lost by sodium to form Na plus. Same way here, to attain stability, one electron gained by chlorine to form Cl minus. And eventually the result is they have become stable, and when they become stable, and that's where the compound formation starts.
Sir, understood.
Okay, right? Okay, so that's what. So this is one type of stability. This is a very simple case, but when you go to higher classes, you will understand there are different criteria for stability. This is one of them, and the most simplest of them.
Okay, sir.
Fine, cool. So fine, we understood why it happens also. Right. So the next thing is, we'll again get to the basics. So now if I want to write a reaction, right? If I want to write a reaction, right? Say for example, I have sodium reacting with chlorine to form sodium chloride, right? Now you understand what you are bringing them to, what chemicals you are bringing together, right? That is what is called as your reactants, right? I'm just going, this is one technical word you didn't understand. Reactants are the ones which are reacting together, making them in contact. Okay, so when I say sodium reacts with chlorine to form sodium chloride, right? Sodium is reacting with chlorine. So which two are the reactants here? Sodium and chlorine are what are called as reactants, right? So sodium reacts with chlorine to form. Now, whenever you see this to form, you're going to form something in that side, right? And that side you form NaCl, and to form what? To form something called as products, right? So if I have to put it in a nutshell, reactants react together to form products. It's as simple as that, right? Whichever you are mixing together, reactants, and eventually that mixing together, whatever you mix will not be there. It would have converted to something else, and that converted to something else is what is called as your products. Okay, right? Now, generally, how do we represent in an equation, in some kind of representation? How do we represent a chemical reaction? If you ask me, this is how we generally represent in simple words. Reactants gives. Now you see this gets converted, and this is represented by the arrow mark, the transformation, right? This is converted to products. This is how we generally write, right? Now, I say reactants and product. If you have only one reactant, one product, okay, fine. Now, if you have more than one reactant, more than one product, right, you are going to use the plus sign. For example, I say sodium is reacting with chlorine, right? You have two reactants there, right? So how do you write it? You write sodium plus chlorine. You see this plus, again, it's like addition, adding the two of them, right? So sodium plus chlorine, now they will react together, the transformation to form sodium chloride. See, you see the difference here. Chlorine, metallic state, no ion. See, just because it's ending with E, please don't again, this thing, it should be either ITE, IDE or ATE. It's none of them, it's NE. No, it's not going to be an anion. Okay, so anyways, sodium chloride. This is what is called as your chemical reaction. Okay. Right? The entire, you use the full names. Sodium, chlorine, sodium chloride. Now you know, too, if at all you have more than one reactant, put a plus in between them. And then this is indicated, the reaction happens, arrow mark, and eventually that side you have products. Again, if you have more than one product, you write plus whatever stuff. Right? Okay, fine. So this is okay. So this is how you represent a chemical reaction. This is, say this, whatever I wrote is what is called as, we generally say it's chemical reaction, right? But this is how we essentially say that this is the representation of the chemical reaction. Okay, now you see, this is going to be pretty difficult. Why it's pretty difficult, I'll tell you, right? Say you have two reactants and one product. What if I have 10 reactants and 20 products? Say 15 reactants and 20 products, something like that, huge number. For every one of them, you cannot write their full name. Anthracene, when I actually go to carbon and its compounds chapter, right? Maybe I'll introduce you to this. I can have a compound name as this entire board I'll be able to write, that much big. For example, let me tell you, say we have short forms, something like LDA. Okay, now you know what is the full form? It is lithium diisopropyl amine. Don't worry about it. This will not be asked in your exams. I'm just letting you know, right? Say sometimes the compound names can be very big and very complex, right? So if at all I want to represent a chemical reaction, this way of representation, that is using the full names, is pretty inconvenient. Okay, right? So for that, we go for what are called as chemical equations. How you have equations in mathematics, just like that, you are going to have equations in chemistry, right? So this is whatever we wrote here is what is called as chemical reaction representation, or you just write chemical reaction. That's it, using full words of the elements or the compounds or whatever it is. Okay. Now, if I use symbols for all of them, we already know now. That's what we have been spending so much time on, right? We already know the symbols. Now you put the symbols and when you write the chemical reaction, that is what is called as your chemical equation, right? So you can maybe take a definition also for chemical equation. Please take down. I'll give you the definition. I hope everybody is sitting with a pen and a paper. Everything which comes out of my mouth is important. Please remember this. Everything which comes out of my mouth, every word which comes out is valuable. If you record it, good for you. If you don't record it, there are no comments. Okay, right, fine. So we are going to take the definition for chemical equation. Okay, please take down. It is the symbolic representation. It is the symbolic representation of a chemical reaction. Right? It is the symbolic representation of a chemical reaction. Right? Okay. So now, if this is a chemical reaction written in full names. If the same thing, if you can write it here with the help of symbols, and that is what is going to be called as chemical equations. How I do I write? I already know sodium. What is the symbol for sodium? Like, can someone tell me?
Na.
Okay, we have been discussing this. It should be very easy, right? And fine. Now, please understand, people. Some elements. Okay. Now, first things first. From the name, first thing you must be able to understand is whether it's an element or a compound. Are you now aware how to do that? Right? Everybody should know from the name. Say, if I see sodium like this, right? Nothing else. Sodium. We see, right? Now you should be able to conclude that it is sodium element, right? But I think when you see sodium chloride, I think you will be able to understand it's a compound. Carbon dioxide is a compound. Carbon is an element. Oxygen, if I just write, right, it's an element. I think that is very easy for you, right? By looking at the name, to understand whether it's an element or a compound is very easy. Okay. Now that if you understand, second step is some elements actually can be, for your level, I can say they can either be monoatomic. Again, how do you have monoatomic and polyatomic, diatomic ions? You have monoatomic, I'll tell you, fine, monoatomic, diatomic elements also. Now, what do you mean by this? Okay. Now, see, for example, I see sodium. Okay, I see how sodium is naturally available in our earth. Okay, now sodium, how is it naturally available? Is in the form of this elemental state, single atomic state. This is how it exists, right? But if I see oxygen element, right? Oxygen element, how it exists in our earth. Can you tell me how it exists in our earth? Is it like O or something else?
O2.
Absolutely,
O2.
right? Oxygen will be O2. Now, why do we write like this? Because this is how it is available in our atmosphere. Same way, nitrogen, how it exists?
N2, sir.
N2. Right. Same way, chlorine exists as Cl2. Right. So that's why we say monoatomic. Like generally, metals will be monoatomic. We'll speak about what are metals and non-metals, but I think you should have some idea what can be examples of metals, what can be examples of non-metals. Sodium, magnesium, calcium, lithium, potassium, all these are metals, right? Your oxygen, nitrogen, phosphorus, carbon, all these things are generally going to be non-metals. Nitrogen, all these things. Okay, so generally you say metals are monoatomic, right? And non-metals are generally diatomic. You can see oxygen, non-metal, O2, nitrogen, non-metal, O2, chlorine, non-metal, O2, fluorine, non-metal, F2, Br2, Ci2. Every non-metal you see will be generally diatomic, or some elements can even be polyatomic. Okay, so I can even write one more. Right, polyatomic. For example, if I take
diatomic is consisting of two atoms, sir.
Two atoms. Oh, sorry, I have to mention that. Obviously, it consists of two atoms.
And
monoatomic consists of only
one
monoatomic only one atom. Sodium 1. Only we don't write in number. That means what? Only one sodium. Okay. Right? If we write instead of this, if I write magnesium, then I write only Mg and nothing else. If I write calcium, I just write Ca and no number, only one. Right? But whenever you go for diatomic species, that is when you go for non-metals, then you have to mention this number 2. Right? If it is polyatomic, some numbers can be like this. Say if at all, like I say, phosphorus in the chemical reaction, like this, they give this word, phosphorus. Generally, they should not be giving. But if they are giving, right? If they are giving, how should you write? Let me tell you, in the chemical equation, you should write P4. Because that is how it exists. That is how it exists in nature, in Earth. Right? If I just say sulfur, we can just write S. But again, they should not be giving sulfur. Don't worry about it. Right? So, but see, but maximum to your level, at least till diatomic, you should know. There can be monoatomic elements, diatomic elements. Now, how do we decide all this? We decide all this just by looking at the nature, how they exist. If they exist only as one atom, then it's monoatomic. If it's a non-metal, then they eventually exist as 2 atoms. Okay, so it will diatomic, or two atoms of oxygen and two atoms of nitrogen. Here, 2 atoms of chlorine. Okay, right. So for sodium, you write Na because it's monoatomic. But for chlorine, you write not Cl, but Cl2. A lot of people do this mistake. Okay, it's not Cl in how it exists in atmosphere is Cl2. You remember this. Okay, now there are reasons for this. I can tell you the reasons. Again, to attain stability. For them to be stable in the atmosphere, they have to exist in this form only. Okay, if at all they are not stable, what will happen? Please understand. Okay, if they're not stable, that means they'll be highly reactive. Now, please remember this point, people. Stability and reactivity are inversely related. I think logically also you should be able to understand. Right? When I'm very strong, when I'm very stable, right? I will not my reactivity will be very less. Say if I'm very stable, maybe I will not be able to move that much. I will not move that much. Maybe I'll not run fast. I'm very stable, right? So that's what you understand. Stability and reactivity are inversely proportional in the sense when one particular element or a compound, we say it's highly stable, right? Then it will not react that much. Right? Then that's why we say its reactivity is less. If this is higher, this is lesser. Right? But if I say for some compound, the stability is very, very less. That means the moment you show it to whatever the conditions, it is going to react because it's unstable. Right? So stability and reactivity are inversely related quantities. Please remember this. Okay, now why am I telling you all this? Is because I told you this non-metals which exist only in diatomic states like this. Why they exist is because they want stability. If they are not stable, what will happen? There'll be so many things around, so many chemical species around, right? So they might form some unwanted chemicals which are harmful to us or harmful to something else or harmful to the earth as a whole, right? So that is why they exist in this particular form. So that they are not that reactive. But again, if I provide the necessary conditions, they can be reactive. Obviously, there are chemical reactions happen naturally. Obviously, we can conduct chemical reactions in our laboratories, right? Okay, so anyways, so a little stability it gives rather than being chlorine, Cl atoms. See, I would say this is atom and this is a molecule, is it not? Because it is made up of more than one atom. So it becomes a molecule. Okay, fine. Anyways, right? So this is how we write, and then now again the same thing will continue. Now you write one of the reactants symbol, second reactant symbol, then obviously this you write as such, the arrow mark, right? And then you go for the sodium chloride. Now if you don't, now this is where all the practice we have been doing will come. You can directly write it as NaCl. Okay, right? This is what is called as your chemical equation. Okay, right. Fine. Now, with this, we have to practice. Lot of questions will come. They will give equations. They will give chemical reactions like this. Okay. And then they'll ask you to write the chemical equation. Right. And that too, they'll ask you to write something called as a balanced chemical equation. Okay. Now maybe I'll give you a very simple picture here. We'll spend some time on it. Don't worry. But in this example itself, I'll give you, right? I give you this, right? And I ask you, write the balanced chemical equation. You written the chemical equation. Okay. What do you mean by balanced chemical equation? Now, balanced chemical equation is one, right? The number of elements or number of atoms on the reactant side should be equal to the number of atoms on the product side. How do I explain this? Please understand. Here you see sodium is there. How many sodiums? One sodium. Okay, fine. When I go to the product side, how many sodiums?
One.
One sodium. Okay. Now, when I go to the reactant side, now for all the elements you have to check. Right? If at all there are n number of elements, n times you have to do this, whatever I'm doing. Now, there are only two elements, sodium, chlorine. So I have to do it 2 times. Okay, fine. Now, chlorine, in this case, you see there are 2 chlorine atoms, and you can very well see here there is only 1 chlorine atom. So that means there's a mismatch. This is an unbalanced equation, right? If there are 2 chlorine atoms this side, there should be 2 chlorine atoms on that side. Now, how do we do it? Obviously, say you cannot just put two like this in between sodium and chlorine. Absurd, isn't it? Because sodium chloride is a single compound, right? So if at all you want to put 2, you better put 2 like this. Okay, you better put 2 before NaCl. But again, there's a problem coming, right? Okay, 2 chlorine atoms. Okay, 2 chlorine atoms. This is for the whole thing. You don't have to put the brackets. Don't put for your just understanding. I'm writing. You don't have to put it. So what I understand is by this 2 sodium atoms, 2 chlorine atoms. That's what I understand. Okay, so 2 chlorine atoms this side, 2 chlorine atoms that side. Correct. That's the equation. Okay, so 2 chlorine atoms this side, 2 chlorine atoms that side. Right, that is okay. Chlorine is okay for me. But again, you check for sodium. Right, you see 2 sodium atoms, but again only 1 sodium atom this side. So what I do, for simply I put 2 here. What happens? 2 sodium atoms, 2 sodium atoms, 2 chlorine atoms, 2 chlorine atoms. Now, this is what is called as your balanced chemical equation. Okay, so this is a chemical reaction. Without these numbers, if we just write only the symbols, right, that is what unbalanced chemical equation. And if you put the numbers accordingly, and we'll speak again about it, we'll spend some time on it, don't worry about it, right? So remember, and if you put the numbers, that is what is called as your balanced chemical equation. You can write, maybe if you want, balanced chemical equation. Right? If you don't write the numbers, then it becomes you can either call it as unbalanced equation, or you can even call them as skeletal equation. Right? A skeletal equation is one which is not balanced. Okay. Sometimes they give the question like this: balance the skeletal equations. Means what? Skeletal equations means the non-balanced equation. You're going to balance it. That's the question. That kind of questions only will come. Okay. What is the time? Oh, we have 5 more minutes. But I think maybe we'll stop here. Okay. So now we understood what are reactants, what are products, how do you represent a chemical reaction in 2 ways. One, full method, writing the full names. Second, going for symbols. And that is what is called as a chemical equation. And we understood what is a balanced equation, what is an unbalanced equation, skeletal equation. And when it comes to elements, you know how to write the formulas of compounds. That you have spent enough time. When you're going to write the formula for elements like this, we understood what do you mean by monoatomic, what do you mean by diatomic, polyatomic. I gave you an example for phosphorus.
Sir, polyatomic is more than 2 atoms, sir.
Yeah, more than 2.
Okay, sir.
Okay. So we saw that also, right? So then we'll spend more time on this. Okay, we'll now maybe then in the next class I'll give you maybe I'll teach you balancing next class. Okay, next class we'll see balancing, and then what we'll do next class itself is I will give equations like I will give reactions like this. You should get me the the balanced chemical equation. Not only the chemical equation, but the balanced chemical equation. Okay, that should be the task for next class, right? Writing chemical equations. Obviously, you should know the formulas. and balancing the equation. That I'll teach you how to do it. This is exactly how we do it. It just comes with practice. There is no say a particular formula or something to this. You just see what is there, how many this side, how many this side, and you count accordingly, multiply accordingly, and you're going to get the answer. Very simple, very simple. Balancing is very simple. Okay, we'll spend some time on that, and tomorrow's class will go in this. Okay, and then once you know the chemical equation, balanced chemical equations, one more, there are a lot of information you will be able to add to the chemical equation. See, this chemical reaction is very large. We are very big things we have to write, right? But since here everything is in shortcut form, simple form, right? There are a lot of other things you will be able to mention here, give information, right? How, for example, I will be able to tell that, say, this reaction happens at 0 degrees Celsius. How do I tell it? I write it above the arrow mark. Okay. Now, you know there are two types of chemical reactions. One is exothermic, another is endothermic. That also can be, some other information can be employed here. What is the pH? What is the catalyst? If at all I told you about catalyst.
Sir, what is
the catalyst?
Sir?
ATM? Oh, yes. Okay, fine. Yeah, that's, again, so we talk about the reaction conditions are going to be in terms of temperature, pressure, something like that, right? So temperature, I know the unit is a degree Celsius or a degree Fahrenheit or Kelvin. Okay, that also we'll see in this, the units. Okay, like that, pressure is a physical quantity, right? That has various units. Okay, so the units can be, say, ATM, mm of Hg, bar, Newton per meter squared. So many different units are there for pressure. One of the unit is what is called as ATM. ATM is atmospheric pressure. Right, ATM is atmospheric pressure. That's the full form, but ATM is just a unit, right? Say 1 ATM, 2 ATM means it describes the pressure, how much pressure is there. So generally we say 1 ATM is the pressure surrounding us in general, near sea level. In Chennai, we can say generally in sea level, near sea level, right? The atmospheric pressure is 1 ATM, we say. That is how it's calibrated. It's too much technical, right? Just to know that ATM is a unit of pressure, means atmospheric pressure, and 1 ATM is the surrounding pressure in our atmosphere, something like that. Okay, fine. So we'll see this kind of thing also can be added, say something like this, say in the bracket, reactants, products, say I can write 500 degrees Celsius, 200, 300 ATM, something, catalyst use this, some ion, something, right? Lot of information can be given in this arrow mark, and there are a lot of other things also you can mention with about, say, for example, sodium. If I write the reaction, sodium plus chlorine gives sodium chloride. I know sodium will be in solid state, right? Chlorine will be in gaseous state, right? And sodium chloride, you will be getting in the form of solution, right? So you will be writing generally aqueous. We'll see about this. Okay, don't worry. So these are also kind of informations you can give, right? So for tomorrow, we are not going to see this next class. I'm just telling you that we are going to see. So next class, what will we see is we'll spend more time on converting the chemical reaction to chemical equations. Not only chemical equations, but balanced chemical equations. That will be our motto for the next class. And after that, we'll go into all this, giving more details to the chemical equations. Any questions from whatever we see or whatever we saw, what we are going to see? Okay, fine. I suppose everything is clear. If not, I think, have I given you my number?
No, sir.
Okay, right. So you can take my number. It's okay, 8939219916. Okay, so you can take this down. So if at all you find you're reading through something or you find something fascinating, so I saw this in Google, something related to chemistry, if you want to discuss, right, you can always WhatsApp me. Don't call me, I don't prefer calls, but you can always WhatsApp me from your number or from your parents' number. You're always welcome to ask doubts, to ask questions, to discuss something, right? Okay, fine, guys. Thank you so much. If there are no questions, we can wind up.
Thank you, sir.
Okay, cool. Thank you so much. Yeah.
Thank you, sir.
Thank you, sir.